Okay, welcome to today's class, and today we are going to discuss about collections part 1. So these collections, okay, we will discuss into two parts. One is we will discuss list and set collections is the one class, and the queue and map. So other collections also we have map kind of collection, but we cannot call it as a collection. That is also we can store a list of records as a key value pairs in a map interface. So that we will see part 2. Okay, this part 1 we will cover only list and set collections and collection interface, as well as collection interface. And also we have a collections class. Okay, we have a collections utility class from the java.util package, where we have some utility methods, and those methods also we can use our implemented collection classes. So that is what we are going to see now. So are you clear?
Yes.
Yes, very clear.
Okay, yeah. Iterable is the iterable is the super interface for all our collections. So iterable is nothing but iterate, so we can read element one by one from the collection classes. So that is the reason this is the super interface. So it is having some predefined methods to read or to traverse our collection. Okay, so we will see what are those. Okay, so okay, introduction collections. So this is what we discussed now, and coming to here. Okay, collection classes. A collection, sometimes called a container, is simply an object. It a group multiple elements into the single unit. Okay, so collection is nothing but a collection of records. Okay, collection of records or group of records. Okay, collections are used to store, retrieve. Collections are used to store, retrieve, manipulate, and communicate aggregate data. So the collections are used to store the data and manipulate the data, and some aggregate functions we can do our collection data. So that purpose only collection introduced in a Java. Okay, what are the Java collections are and refer to collection? Individual objects are represented in a single unit. You can perform all operations such as storing, insertion, manipulation, deletion, etc. This is one more definition. Okay, so we will see. So what is the Java collection framework? Okay, so again I given here. So how it will be implemented? Okay, so we have interfaces in our collection framework. We have classes, and internally what are the classes? We have some of the algorithms also implemented to store the data. Okay, so what we will see now. Okay, a Java collection framework provides an architecture to store and manipulate group of objects. A Java collection framework includes the following: interfaces, classes, and algorithms. So algorithms we will not see. Why? Because it is an internal implementation of each and every collection. Okay, we will see now. So let us learn about those in detail. Okay, interfaces. Interfaces are the Java refers to abstract data types. They are Java collections to be manipulated independently from the details of their representation. Also, they from hierarchy object oriented programming language. So, okay, that's fine. And classes, of course, the classes are the implementation of the collection interfaces. So you can see here. So list, queue, set are the interfaces. Okay. So array list, linked list, vector, and stack. So those are the implemented classes from the list interface. Hash set and linked hash set. Okay. And the tree set are the implemented classes from the set interface. Okay. Priority queue and array queue, array DQ. Okay, are the implemented classes from the queue interface. Okay, queue interface, right? Like that. Why use Java collections? Just now we discussed it, right? So reducing the effort required to wire. Okay. Okay. Reducing the required to write the code by providing useful data structure and algorithms. Java collections provide the high performance and high quality data structures and algorithms, thereby increasing the speed to equal quality. Okay. and unrelated APIs can pass collection interfaces back and forth. Okay, so we can traverse the collections, decrease the extra effort required to learn, use the design new APIs. Why? Because so collections are implemented many algorithms and many data structures and APIs internally. So simply we can use those APIs and methods from that collection classes. Okay, support reusability of a standard data structures and algorithms. So internally many algorithms and data structures are used collection classes. For example, collection dot sort method is there. So internally it is implemented one of the sorting algorithm. Okay, so that is the reason we can directly use. Okay, so we will see this is also one of the map related including map hierarchy here. So we will see now. Before going to the uh, collection example class, you can see the methods available in iterator interface as well as collection interface. So size of the collection, whenever you are having a records, you can see the size of the collection. When you want to check that empty or not, you can check that collection. When it contains any object in the sense whether it be a string, whether it be a any kind of salary, whether it be a object, right? We can see contains. Okay, iterator is the method to traverse, to jump one by one element from the collection. Okay, to array. So we can convert our collection into the array, right? To array. So add element, we can add the element into the collection, and we can remove element from the collection. Contains all, add all, remove all, right? So like that we have. Coming to here, stream and parallel stream are the Java 8. Okay, from the Java 8. So after these collections, we will directly go into the Java 8 features. So at the time we will discuss these two. Okay, so coming to collection demo. Okay, we will see one demo now. So one by one I will explain. Okay, so let me copy this code and run in our API. Okay, okay, what happens, let me see. Okay, so here you can see. So this is the collection. So collection is the java.util package. It is also interface. So whenever you are implementing a class, right, which is nothing but your array list of elements you are storing in a collection. So this is a kind of array list implementation. Okay. So if you want to store data, right, you need to implement one of the collection class. Otherwise you cannot store. Okay. So you can define like this, directly like this also. You can define like this, or you can define, yesterday we discussed it, right? We can define like this also, list also we can take. Why? Because list is also one type of interface, right? List is also one type of interface. Or you can define directly array list also, array list also. So you can create an object like this, you can create an object like this, or you can create an object like this. Okay, no worries. Now see, we defined a fruit collection. I added banana, apple and mango. Okay, just I printed here. Now collection dot, this is the collection, right? Remove banana, so directly I am removing banana. So now after that I printed, what is that, what collection, banana. Once banana removed, we will have apple and mango, that's fine. Now if apple is contains apple, collection is contains apple, it will be true or false, it will be print. Apple is contains, right? We did not remove apple, it will be true. And also we can traverse the collection data using for each. So this is the for each method from the Java 8. Okay, for each method. So element, this is the lambda expression, and inside the lambda expression directly we can print that element. Element is nothing but these are the collection elements. Okay, collection items. Okay, the same, the same we can print using iterator also, Java iterator. Okay, iterator string type. Okay, it equals to fruits dot, so collection, right? Collection dot iterator method is there. So this is the iterator method is there. So we can take that, this is the iterator method. So while using while, so here iterator dot has next is the one method. Has next is the one method. If which means, which is elements, which is as next is, it is having the next element. So like that it will check. Okay, it is having the next element. Then we can print that, or we can take that element, iterator dot next. Iterator dot next will be the same element. If the element is having, then the element is we are taking. Okay, it is nothing but a get method, get kind of method. Okay, if that element is having. So we will see now. So after that we are clearing. So clear is the one method to clear our collection. We remove all the elements. Okay, remove all or clear, we have elements. And also you can see, we can print that collection once it is cleared. Maybe obviously empty collection will be printed. So let me run here. See here, first we have a 3 fruits, we printed here. You can see we got the 3 elements here. After that we removed banana and we printed this collection. So obviously when a banana is removed, apple and mango will come in. And this once we have the 2, right, we check that contains apple. Yes, it is contains, it is true, it is true. Next, for each, for using for each one by one we are reading. So apple and mango is printed, apple and mango is printed. Okay, after that we are using while loop also using iterator. So iterator is the super interface of collections. So for using iterator also we can traverse the collection data. So by using iterator method, that collection, so it will give the iterator. So iterator we will check as next, which means element is having. Okay, if it is having next element, the next element we are printing. Okay, so that is also we printed. After that we used clear method. So using clear method we are clearing all the elements from the collection and printing the collection. You can see empty collection here. So are you clear?
Yes, very clear.
Yes,
Okay, thank you. So let me go to the next example, output. So output here we are having here. So whatever direct program. Okay, so this is also done. So we will see. So one more some of the methods using collections. Okay, so yesterday we discussed, we have a collections class also, utility class. Okay, this is the collections class where we are having some utility methods or static methods. Directly we can use those methods. So array list of, we will see array list of strings sorted alphabetically using utility class. Array list class itself not providing any methods to start. Okay. ArrayList is a simple Java method, Java implemented class from the list interface. But whatever these methods are there, right? So these methods are either collections class, utility class, or collection interface. Okay. We will take some of the methods from the collection interface. We will take some of the methods from the iterator. We will take some of the methods from this collections class. Okay. So we will see this example. So let me copy this collections demo. I'm copying this. Just I'm printing here. Okay. So errors are because of that imports. Let me import. Okay. This is yesterday only we saw, right? This one. Java.util list. Okay. We are importing list. This is only the student list. Okay. Not a list. All errors are gone. The warnings also we will remove. Okay. That's fine. No issue. So here you can see. So original list, after sorting is a list, after reversing is a list we printed, after shuffling a list, and also frequency, how many times it is repeated near us. Okay, the duplicate elements also we printed. So using these three methods, one is the short method, one is the reverse method, one is the shuffle method, and one is the frequency. We are using frequency to count element. Okay, to count element. Okay, so you can see here, you can see here, here we have Neeraj, Mahesh, Arman, Preeti, Sanjay, Neeraj, and Jahir. So, and also this list interface, which means array list. Okay, list. Okay, this list interface will follow the insertion order, will follow the insertion order, and also it will allow the duplicates. Nearest is allowed two times, right? Even though we print we are adding, we will see the output. Okay, it will add the duplicates, and it will add the null also. We can print. Why? Because null is also one type of string, right? Null is also one type of string. Inside, when we are having, when we are adding inside the string, it is a string. It is not a null. It is a string of string characters, null something. Okay, so we can add these things. So let me run this. Okay, let me run first the original list: Neeraj, Mahesh, Arman, Preeti, Sanjay, Neeraj, Jahir, null and null. Okay, sorted list. Okay, from A to Z, from A to Z it is sorted. Okay, it is sorted. So null is not considered as a name, so it is given the end of the string. Okay, so the names are sorted, and after that reverse, the reverse order also, from the reverse it is taking the starting one, and from the Z and Sanjay, and null is the first. After Z it is taking as a null is the first priority, and Z is the end of the characters, right? So Sanjay, Preeti, Neeraj and Mahesh and Arman. After that, shuffle list. Shuffle means any order. So any order, nulls are coming between the array, array list, and checking the occurrence of nearest. So nearest is we are counting because of the frequency. So you no need to write your logic using this method. It will be internally checking if the nearest is coming, count one. If the nearest is coming second time, count plus plus. So the frequency method will do all the things. Okay, if you are passing the list and if you are passing the element, so it will do the list and it will pass the element. So that is what this frequency method will do. So like that, we can use all utility methods from the collections class, and the utility methods from the collection interface, and utility methods from the iterator interface also. Are you clear?
Hi, Beer. I got a question
Mm.
with this. I saw that the end of the list you add two nulls, but
Mm.
those are string values, right?
Yeah, a string. It is nothing but a string, right?
It's a string, but when you're sorting it, it leaves those values at the end of the list. It
Exactly. Let me run. Okay. Let me run.
uh-huh.
So why it is end of the string? Okay. Whenever we are sorting, right? Whenever you are sorting, right?
Mm-hmm.
So the algorithm is very intelligent. Okay. Very intelligent. Why? Because even though it is a string, even though it is a string, but it is a null. The value is null, right? The content of the string is null. So that
Mm-hmm.
is the reason it is given that last priority among these all strings.
Okay, I see.
Got
Okay,
it, right?
so yes, part of the logic of the method sort that
Yeah, but
if the
reverse
string.
order, reverse order, reverse order.
Mm-hmm.
It simply it will not check the content of the string. Reverse order, it will check the reverse the last element to the first element and the last element to the second element. Like that, it will take. It will not
Mm-hmm.
go to the inside the content of the string. Why? Because it is not doing any sorting order, right? It's just shuffling. Just so sorry, reverse the order. So instead of taking a extra weight to check the each and every content of the string, it is simply reversing. It is simply reversing the all the strings here, whether it is a null, whether it is a normal any string. You got it, right? Based on the reverse and sorting. Sorting will
Okay.
take each and every element, it will contain. Why? Because see, nearest we have a two times here, nearest we have a two times, and also it is checking the nearest and nearest, it will give the side by side. Okay, if you are giving one more name contains
Mm-hmm.
n. Okay, n. So Naresh, I will give the Nares, it's Naresh. So
Mm-hmm.
it will come first. Why? Because after n, the n is the starting character of all these three. But after n, a is the first priority. Now Naresh will come first and Neeraj will come second and Naresh will come third. Let me run. Okay,
Exactly. Mm-hmm.
exactly. The sorting order will check. You can see here. Naresh is coming first and Neeraj is coming later and
Next.
later,
Mm-hmm.
right?
Mm-hmm. Right.
Exactly, it will check the each and every content. So whenever it is checking each and every content, right, it will recognize the null value. So that is the reason it is giving the last priority. Got it here?
Yeah. Yeah. Okay. Yeah. Thank you, Vir,
Okay.
for
Yeah,
clarifying
thank you.
this.
Yeah,
Thank you.
yeah. Now, so list. So we already discussed it, right? So list interface, we have list interface, we have uh, collections of child interface. This is the child interface. You can see here. This is the collection child interface. List is the collection child interface. We have a four kind of implemented classes. One is the array list and the linked list and the vector and stack. Okay, so these classes are very important when you are working with the collection of data, and you need to know when the array list we can use, and when the linked list we can use, when the hash set we can use, when the linked hash set we can use. All we will see now. Okay, the use cases. Okay, we will see. So coming to here, so list interface is the child interface of the collection interface. If you want to represent the group of individual objects where the duplicates are allowed, instance order is preserved. Okay, these are the two things of the main behavior of the list. Okay, group of elements, individual objects which are duplicates, which are allowing the duplicates, and the insertion order preserved. Insertion order means what way you are inserting elements. The same way we can print original list. You can see the original list. Original list means the order of what you are adding, the order of what you're adding. The first you added Neeraj, and second you added Mahesh. You can see here and here you can compare. Third, Amran and Preeti, Sanjay, Neeraj, Naresh, Jahir, Null. So whatever you are adding, the one by one elements is the order, right? The order is nothing but insertion order that will be preserved. So it will give you the same order. Okay, that is the behavior of the list. Okay, so we can preserve the insertion order and we can differentiate the duplicates object by using index, and index will play a very important role in the list. Okay, and also use this the user of this interface as a precious control over the list each element is inserted. Okay, so that whenever it is required, so that we will know based on the index and insertion order. The list may contain the contain a multiple null elements also. Just now we added, right? Why? Because it is also one type of string. So list interface can contain duplicate elements. So duplicate elements we can add. So all the implemented classes, array list and vector, array list and linked list and vector and stack. Okay, so let's see one by one example here. List demo. So let me take here. Let me print. So these are the very, very simple. So once it is done, right? So everything will be done one by one. But you need to aware of the collections. Okay. Okay. You can see here previous example only we discussed, right? Like we can directly create the list interface, right? Or we can directly create the array list equals to new array list of string. Okay, so this is the string of elements we given. Element 1, element 2, element 3, element 4, the string kind of elements we given. So we are printing the list. Okay, so now we are adding the null also, null elements. Okay, but here you can see, so directly we are adding null. Okay, null also we are adding. So here also we are printing. We will see what kind of it will come. So you can add directly string and you can directly add null also. Why? Because null is also one type of directly we can recognize null as a null, right? So we can see, and also insertion order. So this will take 0, and this will take insertion order also. We already see that now. So zero element, we will take that zero element as a element 1, and we can see here the we will add 0. Okay, uh, by referring that. And also we can take that fourth element. Yeah, already. Okay, we given that number also is there. Fourth element will be the, sorry, 0.4, right? 1, 2, 3, 4. Okay, 0.4, maybe 5 will come. Yeah, fourth element it will come. Okay, now we will see that. See here. So element 1 and element 2, element 3, element 4, we already added. So even though we are added directly null, it will take the null also. So inside the string it will take, or inside the string it will take as a string null. If you are directly adding a null, it will also take a null. Okay, directly it is taking. So this is also very, very important question in our interviews. Okay, you can check. So elements. Okay, elements also added. Okay, elements also added. So insertion order. So 0, 1 and all. So here also we are printed. So that is also fine. Okay, so here we are printed list, right? So, and after that we will have this list also, okay. So now you can see, so list is increased, right? After adding this one, list is increased. So that is the reason we are getting more elements. Okay, including duplicates. Now you can see 0 0 means the first one, 4 means the second. No, 0 means this one, it will come. Okay, we will see. Element 1 it is coming, element 1. So 1 2 0 1 2 3 4, the null value is the fourth place. So that is the reason we are getting a null element here. Or did you get what we are trying to get here? Not these elements. So from here the 5 elements and the 2 elements, and the again 5 elements. So 5 plus 5, 10 plus 2 elements, 12 elements. After 12, the first element 0 place we are getting as element 1, and the fifth element we are getting as a null here. So are you clear?
Yeah, it's clear.
Yeah, fourth element. Okay, fine. So here is the output. So we can see, and we will take the example of a linked list. See, remaining all are same, but you need to uh, aware of what collection where we can use. Okay, so let me copy this. So we have some internal methods also, collection to different collections based on their implementation. We will see that. We will see those. What it is happening.
I think it's missing the main method.
Okay, good, very good, good catch.
Mhm.
Yeah, good catch. Thank you. Okay, so we will see now. So fruit. So we are adding banana and apple in here. So we are printing a linked list. So after that we added second place. Okay, so replace. So you can see here linked list. So whenever we are doing a data manipulation, right? So linked list is the best suitable for this one. Why? Because linked list is having a node addresses. Previous node address is having a current node, and current node will have the next and the previous node addresses. So whenever you are adding, so it will easily shuffle the elements with the less steps compared to array list. Okay. So the second position we are adding watermelon. Okay. The after second position we are adding the watermelon we are having here. So and also add first, and also we have that add first is the method in a here in a linked list. So add first we can add that starting of the element. Okay, add first element. So add last. So these are the linked list internally we have these methods. Okay, so orange. So this can be added as a last. Okay, after that more fruits. So you can add grapes and pears. Okay, so pears. Okay, pears. So here we have add all. So add all fruits. So we will see. Okay, so these fruits also we are adding for the fruit. This fruit. Okay, this list. Okay, so add all will add the this list to the these fruits. Okay, we will see. So list one to the list two it will add. So let me print. See here. So initial linked list banana, apple, and mango. Okay, that is banana, apple, and mango. So after adding second place is a watermelon. See, after adding second place is a watermelon. 0, 1, 2. The second place is the added. Why? Because it will take index position. It will take the index position. So it is nothing but a third element of the second position of print. 0, 1, 2. Second position is the watermelon. That's fine. Now the third, the here we added add first strawberry. The strawberry added the first element and remaining list as it is. Okay. And after that, orange add last. Add last is the method. Add last is the method and add first is the method. Okay. I'm talking about these methods. So add last strawberry. After that, orange is added. Okay. Now we created one more list. One more list. Okay. More fruits. The list name was changed. More fruits. Add grapes and pears. So these list is added to the first list. Fruit list I added. Add all. So instead of adding one by one, add all in the sense collection. This is also collection, right? So we are adding. So add all. Add all it will take the collection. So of course list is a collection, right? List of a collection of list, right? So we are adding all this here. So now you can see here. So the end of the list is added these two fruits. So are you clear about this linked list as well as the methods? Add first, add last, add replace the element. So not replace, add in an index position, and add all from one collection to another collection. Are you clear?
I have a question. Sorry, I always have a question. Sorry, Vir, for about that.
Hmm,
But I'm very
hmm.
interested in the and in the class. Uh, this method at all, does this method belongs for the linked list or is for the collection?
No. Good question. So now we will go to the here. Okay, we will go to the linked list class. So you can see here linked list. Are we having any method here? Add first. Let me take. Actually, linked list is implemented from the queue. Okay, not from the uh, queue. That is also queue is from the. You can see here. So this queue. So
Mm-hmm.
you can see here. You can see here. It is implemented from the queue. Got it? Queue. So queue is having add first, add last kind of methods. Queue interface. Did you get it?
Mm-hmm. Okay. Yeah.
You get it? Yeah.
Mm-hmm.
So whenever we are using that methods, right, whether you will get that directly from the collection
Mm-hmm.
or the implemented interfaces. So queue will have this add first and add last. So we will see now. So like that we will see. So directly we can go here. You can see here. So it is implement extended abstract sequence list,
Abstract the
and
queue.
also, yeah, and also DQ. DQ is the interface. You can see here. DQ is the interface. It is implemented DQ.
Mm-hmm.
Directly DQ implemented from the extended
Queue.
from the queue. So yeah,
Mm-hmm.
we will see here. We will see here. So DQ we will go. So DQ directly extended from the queue.
Mm-hmm.
Okay. So this DQ is having add first. Okay. You can take any method from the parent, right? So this is the from the DQ parent. Got it?
Yeah.
Add last. Here it is adding method. So this is Java library. Okay. JDK library.
Mm-hmm.
Yeah. So like that, we need to remove last also it is there. Okay. Remove first is also there. Okay. So we can use these kind of methods from the collections. So Q is also collection, right? So DQ is from the one of the interface. So
Mm-hmm.
see, it is implemented from the this queue, right? So we can take any method from here or here or here or here.
Mm-hmm.
Got it? Got it?
Yeah.
Okay. Fine. Good question. Now we will go to the next. Now you can see the difference between array list and linked list. Okay. Difference between the array list and linked list. So you can see the difference between. So just now we discussed it, right? So now we will see the exact difference and use cases of these two. So array list internally uses the dynamic array. This is the one type of data structures to store the elements. Okay, dynamically. Why? Because these lists are increased dynamically and decreased dynamically. So this is not a fixed size, right? Arrays and array list. Difference between arrays and array list. Arrays are fixed size and lists are dynamically increase. So that is the reason dynamic array implemented. Dynamic array dynamically increase and dynamically decrease this array list. So store the elements. Linked list is internally uses the double linked list, which is store the elements. So it is internally implemented the double linked list. Okay. So manipulation with array list is slow. Just before we discussed it. Internally use the array. If any element is removed from the array, all other elements are shifted in memory, which means if the first element is removed from the out of 10 elements, so second element will come to the first place, and third element will come to the second place, and the 10th element will come from the ninth place. So like that, it will shuffle all the elements. Okay, to uh, reach the, so for the efficient memory wise. So it will remove that empty element, right? It will do like that. Here the manipulation with the linked list is faster than array list because it uses the double linked list. Just now we are saying, right? So the middle element, you can take the fifth element. Fifth element will have the address of the first element, and first element, the fifth element will have the next address of the next element, right? So it is a bit shifting. It is a single bit. It is not all the memories. So it will take the one of the bit from the latter, and it will directly merge that bit. Okay. So it will require the less memory. Okay. So it is the double linked list. So it no bit shifting. It is required in the memory. Okay. An array list classes. An array list class can act as a list only because implemented list only. Linked list can act as a queue. Why? Because and both list and queue. Why? Because you can see here it is implemented from the list as well as implemented also queue. So it is have a two kind of different behaviors. Got it?
Yeah, I got it.
Yeah, I got it.
Okay. So array list is the better for the storing and accessing data. So directly, if you directly store and directly take the data, it is better. Linked list better for the manipulating the data. So whenever you are removing, whenever you are adding, whenever you are replacing, whenever you are adding first, adding last, and removing mid of the element. So such kind of elements, such kind of operation, array list is the better. Okay. The memory location of the elements or array list is contiguous. The location of the element is linked list is not a contiguous. Okay, maybe contiguous in the sense the elements will be the insertion order, it will follow and take, right? So this is location of the elements. Linked list is not perfectly sequentially, it will not give. Why? Because it will be internally following the linked list, and it will have the address of the next element and all, right? So whenever you are removing here, it is directly take the address of the next element. So that is what here the little difference. So generally when array list is initialized, the default capacity is 10 and assigned to the array list. So every collection class will have a default size, and capacity also. Capacity is, for example, size is 10. The capacity is 75%. Okay. So whenever the list is increase reach to seventh element, eighth element, right? So it will increase. It will add one more 10 more capacity, 10 more elements by calculating internally. So like that, it will increase and decrease. The same way, it is the capacity is the there is also no default capacity in a linked list. The linked list empty list increased when the list is initialized. See here. So in array list, it will be having the default size, but here it is not having the default size. Why? Because it is dynamically increased by because of that list and double linked list. So that is the reason it is not having any capacity here. So that is also one type of difference between here. So whenever we are having a clear understanding on both the classes, right? We got to know these kind of differences. And to be precious, array list resizable array linked list implements the double linked list of the list interface. So it will be also implemented double linked list, right? So, and queue from the it is implemented from the it is a resizable array. So dynamic array means resizable, which means increase and decrease. So these are the differences. From the differences, main points are capacity wise. We can say it is a default capacity is a 10. It is no default capacity linked list. Okay. So empty list will be created when the linked list is initialized. Why? Because it is a kind of shift operation will be there. So and also it is implemented from the dynamic array. It is implemented from the double linked list. Okay. And for the manipulation of elements, it is not good, and manipulation of elements is a good. Okay. List is better storing data, and it is the list of better for the manipulating data. Okay, that is what differences. So previously we have that linked list, double linked list, and single linked list, only one or two. But now after discussing these two collection classes, we got many differences here. Are you clear?
Yes, of course.
Yes.
Okay.
Yes.
Okay. Okay, vector and yeah, here I will not execute these two classes. So you can whenever you are doing practice, right, you will have all these classes here. You can copy and paste here, so you can see here. So vector and stack are the synchronized classes. Okay, synchronized classes from the uh, list collection interface. Okay, collection interface. So these are the collection 1.0, the first version of these two classes are introduced to Java framework. So which are synchronized. Later, they realized we should have non-synchronized classes also. So that is the reason these two classes are added from Java 1.2 version. Before 1.2 version 1.0, we have two classes only. Okay, those are the thread safe and synchronized classes. So this is the stack. So it is contained the push and push operation, and also pop operation. Pop removes the last element and push add the elements here. Okay, these are the two kind of operations in the stack. So method adds the element in the stack, and pop removes the elements from the stack. Okay, these are the two kind of operations you can see here. So using for each, you can order. This is the for each from the Java 5. Okay, so this is one type of, this is enhanced for each. We can directly take that type of element and type of list here directly. Stack kind of list here we are taking. We are printing here. So are you clear here?
Yes.
Okay. So now this is the stack, and vector also, it is a one kind of elements here. That's fine. So now coming to the set interface. Okay, coming to the set interface, I think time is up today. So we will discuss the set interface. We have three different important classes. We will discuss tomorrow's class. Okay.
Okay, sounds good.
Okay.
Thank you, Nabir.
So yeah, why? Because we need to discuss about performance related and data structure implemented on this set, and what kind of implementations of internally implemented hash set and tree set and linked hash set. We will discuss tomorrow's class. Okay.
All right. Yeah. Thank you, Nabir.
Yeah. Yeah. Thank you. By EOD, I will upload this class. Okay.
All right.
Yeah.
Thank you. Thank you so much, Vic.
Yeah.
Thank you, everyone.
Thank you.
Night.
Good night, everyone. Bye.
Thank you.